Now again dear friends, what is meant by the transport number? The same thing, but how it is determined by the moving boundary method. So the question can be the different from, that is, describe a moving boundary method for determination of transport number of ions. Now let we discuss about the moving boundary method. Hittov's method, though easy to carry out, but does not gives the accurate result, particularly with dilute solutions. Hence, this method has been largely used as a more direct method called as moving boundary method, in which the rate of movement of the boundary between two ionic solution is measured. If we have to determine the transport number of the cation, that is, let's suppose the potassium ion in KCl, what we have to do? We have to choose the another electrolyte called the indicator electrolyte, having a common anion with the salt under study. Here the chloride ion, the cation of the indicator electrolyte must be slow moving as compared with the cation whose transport number is to be determined. Here lithium chloride is purpose well because lithium ion moves more slowly than the potassium ion. This prevents the blooming of the boundary line. मतलब क्या करता है, दिस प्रिवेंट द ब्लूमिंग ऑफ द बाउंड्री लाइन, मतलब उसको बाउंड्री लाइन को जो है वो कहीं ना कहीं पे ब्लूम नहीं होने देता है, इधर उधर नहीं होने देता है. ठीक है दोस्तों. द apparatus used here, आप आज देख सकते हो, consist of an electrolytic cell of the form shown in the figure. The middle part of the left limb being a vertical tube of the uniform cross section, सेम होगा उसका विड्थ क्रॉस सेक्शन. द इंडिकेटर सोल्यूशन जो कि लिथियम क्लोराइड हमने लिया है ना, लिथियम क्लोराइड जो है ना वो क्या है, उस पर्पस उससे अच्छा सॉल्व होता है पोटेशियम सोडियम लेने से ज़्यादा, स्पेशल पोटेशियम है ना. सो द इंडिकेटर सोल्यूशन लिथियम क्लोराइड इज प्लेस्ड इन द लोअर हाफ ऑफ द लोअर हाफ एंड ओवर दिस द सोल्यूशन ऑफ द पोटेशियम क्लोराइड. लिथियम क्लोराइड क्या किया जाता है नीचे के लिम्ब में और सोल्यूशन ऑफ पोटेशियम क्लोराइड ऊपर के लिम्ब में. ठीक है ना. उससे क्या होता है, द सोल्यूशन ऑफ पोटेशियम क्लोराइड अलाउड टू फ्लोट टू प्रोड्यूस द शार्प बाउंड्री एट B1 बिटवीन दी टू सोल्यूशन. दो सोल्यूशन के बीच में क्या होगा, B1 में एक शार्प बाउंड्री प्रोड्यूस होगा. आप ये यहाँ पे फिगर को एक बार अच्छे से देख लो, डायग्राम को, मूविंग बाउंड्री मेथड में. ठीक है ना. फिर से एक बार कि एक्सपेरिमेंटल सोल्यूशन पोटेशियम क्लोराइड ऊपर के इसमें लिम्ब में या ट्यूब में है, लिथियम क्लोराइड इज इन अ लोअर लिम्ब. The indicator solution is there and the boundary is forming at B1. The remaining, the adjustment or the setup is here, you can see over here. Okay, so now let we move further. During the experiment, the potassium ion which originally occupied the volume between B1 and B2 now have migrated toward the cathode. In the B1 and B2 between that, the x and m square is the cross sectional area. If it is not the if the x m square is the cross sectional area of the tube, then the volume between B1 and B2 will be right, we can write as a xl, that is meters cube, m cube. If concentration, that C is the concentration of potassium ions in equivalent per meters cube, then amount of potassium ion in the given volume is equals to x by C equivalents. Now from the equation 1 we have that NC do Q, that is coulombic charge upon F, into x by C, or NC is equals to x by C F upon Q. If current of I ampere is passed for t seconds, then Q, coulombic charge, is equals to Q is equals to IT, and F is the Faraday, that is Faraday's constant, is equals to 96500 coulomb. So this is, dear friends, all about the determination of the transport number by the moving boundary method, dear friends. Okay, for this video this is enough. Now let we again meet in a next video lecturer. Till then, bye bye.